Other way. How about there? I'm on. Awesome. So hello, in case you haven't figured it out yet, I'm Jeremy Clark, and I'm going to talk about task and await in C#. This is one of those things that was difficult for me to learn and became extremely useful to me as a developer. And in fact, it's become more important because basically every new library that comes out has async methods in it. So I kind of fumbled through it for a while, saying, okay, I'll kind of copy and paste things and tweak a few things and cross my fingers and hope it works. Not a great way to program. So I struggled through it, and hopefully I'll save you some time from getting over some of the hurdles that I had to go through. So that's basically why I'm here. If you want to get the slides and code samples, you can visit my website, jeremybytes.com. There's also links to articles and various other things on the topic. So there's lots of materials out there. Let's go ahead and just get started. In the .NET space, there's been a lot of different asynchronous patterns over the years. I've been doing .NET since .NET 2.0. So I used to feel like a latecomer, but that was 2005, which is now like 13 years ago. So I don't feel like a latecomer anymore. We kind of had a couple patterns come through. There was the asynchronous programming model, or APM. There was the event asynchronous pattern, or EAP. And then there's the task asynchronous pattern, or TAP, which is kind of where we live today. We got to have all these little cool three-letter, I don't know, acronyms, is that the right word? And, you know, it's crazy all the stuff that we've had to go through. Fortunately, it's not the same number of data access methodologies that we've had to go through, but there have been a lot out there. Now, back in the day, I actually used the asynchronous programming model, and this was method-based. And it was based on a pair of methods. There was a begin something something and an end something something method. And the begin method would return an iasync result that you would then pass to the end method. And I was always confused how to do this. I had to look it up every single time. So fortunately, our language and environments keep getting better. So, you know, the team at Microsoft's always trying to improve things and make things better for us. So they said, okay, let's do something simpler. How about the event asynchronous pattern? The good thing about this is that it's event-based, as you might guess from the name. And generally, we have a method such as getDataAsync that would kick off an asynchronous process, and then there would be an event that would fire once that async process was complete. So this was great because it's really easy to use, because the second thing programmers learn is how to hook up an event handler. Right? The first thing we learn is console.writeLine, hello world. Second thing is button click, right? So that's the second thing we learned. So it's very, very easy to use. But it wasn't very powerful, and it was pretty limited. And then it kind of suffered from a few problems, such as what if an exception or something happened during that asynchronous process? Well, then the event never fires, and now what? So there were some shortcomings to it, and so with the I think it was .NET 4.0, we got the task asynchronous pattern. And as you might guess from the name, this is task-based. And a task, and generally what we have is a method that will return a task or a task of T. So when we're talking about a task of T, the generic type parameter, would represent any kind of payload that we're expecting to come back from this. Now, when we're talking about what a task is, a task simply represents a concurrent operation. It's really easy to think that we're talking about threads here. Stop thinking about threads. When you're using task and await, you don't care about threads. Well, you kind of do, which we'll see. But in general, we don't worry about it. It's up to the really smart people who build the compiler, build the jitter, build the runtime to figure out whether another thread is needed in these situations. In fact, there's a lot of times where task will not use any additional thread resources at all. And that's cool, because it saves all of that overhead. The really cool thing about task is it's extremely flexible. So we can chain and combine our tasks in different ways. So I could have a task that kicks off 5 child tasks that run at the same time. When all of those are complete, I want to do something else. We can have a task that runs when it's complete, then another task will kick off. When it's complete, another task will kick off. So it's extremely powerful, extremely flexible. Now, the downside of that is with great power comes great complexity. And that's actually the problem I ran into when I first looked at task. Because basically, every time I looked at task, like when .NET 4.0 came out, it's like, oh, task, this is important. I can tell it's important. And I went and looked at it, and I'm like, this is too complicated. I don't have time for this now. I'll come back to it later. I did that for about 2 years until I just could not put it off any longer. So what we're going to do is start off by writing a bunch of code. The rest of this talk is code, more or less. Is that okay with everybody in the room? Okay, good. I like to hear that. I'm sorry, it's way too late in the conference for a woohoo, but I appreciate the effort. Let me just run the application. I always amaze people with my UI development skills. So this is a WPF application that has 3 buttons and a list box. Ooh. Right now, these don't do anything, and we're going to change that. Now, you'll see I have a button for fetching data with task and a button for fetching data with await. So we're actually going to do the same operations using both task and await so that we can understand how all of this works a little bit better. The things that we're going to do is we're going to get data. Well, actually, we're going to call an asynchronous method to start with. When it's done, we're going to retrieve data that asynchronous method returns. And then we're going to look at, OK, how do we handle exceptions? If something goes wrong in that asynchronous process, what do we do? And then we're also going to look at cancellation. If I want to cancel this process once it's started, how does that work? So those are the things that we're going to be looking at today. So starting off looking at task, before we actually do any code, I'm going to open up the library so we can see the method that we're going to be working with. I'll just collapse this guy for now. So this is our person repository, and this is actually using an HTTP client to get data from a JSON service. And if we look at that method that says get async, the second one from the bottom, we can see that this method returns a task. And in fact, it returns a task of list of person. First thing you want to get used to when you're dealing with task is nested generics. So in this case, what this means is that I have a task, which is something, again, represents a concurrent operation. And at some point in the future, I should get a list of person objects out of this. So that's ultimately my goal. I'm not going to be talking about creating our own asynchronous methods because that's a much bigger discussion, and I actually have a full-day workshop that goes into all of those interesting details. What I am going to do is just pop open this method and show this first line, which is an await task.delay 3000. So what this will do is it will pause operation of this method for 3 seconds. Task.delay is very similar to thread.sleep in that it will pause operation of our application. But the difference is you don't have to feel quite as dirty about using task.delay as you do thread.sleep. The problem with thread.sleep is basically it just does a while loop and goes until things are complete. So it's a blocking operation, it's taking thread resources. It's a horrible thing. And of course, we only do it because we know there's something else wrong in our code. It's like, I don't know why, but if I pause for 500 milliseconds, it works. So I'm just going to put this in here. The other thing we use it for is so that when our boss asks for performance improvements in the future, we can just go remove all the thread.sleeps, right? So task.delay operates like that. It will go ahead and pause operation of the method. The next line won't run until after 3 seconds is done, but it doesn't use any thread resources. So it's extremely efficient. Now, again, if you find yourself using this in the real world, there's probably something else in your code that you want to deal with. But again, you don't have to feel quite as bad about using it as you do with thread.sleep. I'm putting this 3-second delay in so that we can actually see an asynchronous process happening. And in fact, in our world, I'll also be showing that we're using a separate thread. So let's go ahead and use this. Now, my application is a WPF application because XAML is awesome. Any XAML people in the room? Free. OK, that's OK. I will forgive the web programmers in the room. And actually, before I go on, I don't want the web programmers to tune out. Because task and await is, I would say, even more important in the web world. Because when we're talking about, like, for example, how IIS works, there's a limited number of threads that IIS has that will handle incoming requests. So if we block those threads while we're going out and making a service call or something else, that's one more request that our server cannot take. Whereas if we can offload that somewhere else, then our request threads are free to go ahead and keep grabbing those incoming requests. So this is actually more important in the web world. But it's easier to demonstrate with a desktop application, which is why we're using it. Okay, so I have a couple button-click event handlers set up. I don't normally code in the code behind it by forms, but we're keeping things simple so that we can focus on this asynchronous programming thing. Okay, so I have my fetch with task button. So what I'm going to do is new up an instance of our repository. So we'll say var repository equals new person repository. And then I want to call the getAsync method. Now, I might not know exactly what's going on with a library method that I'm calling, so I actually use Visual Studio to help me do a bunch of things. So I know it returns something, so I can say var result equals repository.getAsync. And then the cool thing about var is it's strongly typed, and the compiler can figure it out. So I can hover over this, and it actually says that this is a task of tResult. And then if we look down at the bottom of that box, we see that tResult is a list of person. So this is telling me that this is, in fact, a task of list of person. Should not be a surprise, since that's what we saw when we looked at the code. But I don't always have access to the source code of the libraries I'm working with. So to make my code more readable, we'll spell that out. Task of list of person. And then we'll change result to people task. Just like that. Okay, so now I have a task. I've kicked off an asynchronous process. I have a task. Now what? Well, if you're just kind of exploring what's available to you, the most tempting thing to do is say people task.result. And the reason for this is that result represents that list of person that we're being promised. The problem with accessing result here is that if we try to access result before it's populated, then it blocks the current thread. So I just ruined any asynchrony that I was adding to my code. So that's the first problem. The second problem is, in this case, I'm in a WPF application on the UI thread. So if I try to access .result here, I'm actually going to create a deadlock. Because the UI thread is waiting for that task to complete. The task is waiting for the UI thread to say it's OK to give them data. You end up with a deadlock. So accessing task.result here, bad thing. OK, so what do we do? Well, instead of accessing result, we set up what's known as a continuation. A continuation just means, hey, when the task is done, I would like you to continue by doing another action. So I will say task.continuewith. And this is where we kind of run into the next problem when we're coming up to task. Because, of course, we say, well, I need this continuation. Let's see what parameters it has. Well, before we look at the parameters, look at the number of overloads. This one method has 40 overloads. Yeah, this is enough to scare me away and saying, oh, I don't have time for this. So that's OK. So step one, a lot of overloads on this one method. And there's a lot more than this on task. The next thing is I say, OK, well, you know what? The first overload is probably the most commonly used one. Let me look at that. And I look at the parameter type, and it says action of task of list of person. Action of task of list of. That's enough to make me turn around and go home right there. We talked about nested generics already. It's getting worse. Well, what action is, it's a built-in delegate type in the .NET framework. And in this case, it represents a method that takes one parameter and returns void. And the parameter type is the rest of this generic type. So it's a method that needs to take a task of list of person as a parameter and return void. Thinking, OK, I can write a method with that signature, so let's go ahead and do that. So we'll say private void, and I want to populate the list box. So we'll call this populate list box. It takes a task of list of person as a parameter, which we'll call, I'm going to call it task. And then I can take this method and paste it as a parameter, just continue with. Red squigglies go away. That makes me happy because I hate red squigglies in my code. They make me very nervous. Now, this method, populate list box, is going to run when the task is complete. So I can say task.result. Yeah, I know I told you not to use task.result, but you use it here in a continuation. And that's because the continuation will not run until the task is complete, and at that point, result will be populated, assuming we went through the happy path and we didn't have any exceptions. So since this task.result is a list of person, I'm just going to create a method level variable to hold this to make my code a little more readable. List people. And then I'm just going to iterate through this collection and put it in my list box. So for each person in people, person list box, can't type this late in the conference apparently, .items, .add, person. Woo, okay. That looks pretty good. Okay, so I call my asynchronous method, it gives me back a task. On the task, I add a continuation. This method will run once the task is complete, and it will grab those items and put them into my list box. That looks pretty good. Okay, so let's go ahead and run this and see what happens. So we'll run the application, click on the button. We do have to wait the 3 seconds, which is a really long 3 seconds, especially when you're on stage. And then what we find out, there's an error. Yeah. So, oh, wow. That's scary. It's saying it can't load Newtonsoft JSON. That was not the error I was expecting. Okay, I'm going to do a rebuild. Hope for the best. Build. Try this again. That is not the error I was expecting. I was expecting a much different error. Oh, you know what? My network's not turned on. I try to do these with no network required as much as possible. To rebuild again. Come on, you can do it. If NuGet is not cooperating with me today, I will be very sad. Okay, so here's what we're going to do. Too early in my talk to jump to the completed code, but I'm going to do it anyway. First of all, making sure that this and this one is working. Okay, I'm not sure why I'm having problems with Newtonsoft JSON. So what I'm going to do is do a little bit of copy and paste of. Please ignore the man behind the curtain. Fill in the rest of this. And everything out of. Okay. Let's run this again, and hopefully I'll get the error that I'm expecting. Please? Yes, thank you. Okay, this is the error I'm actually expecting, assuming that Newtonsoft JSON is getting to my machine appropriately. And this is something that anyone who's done desktop programming and tried to do multi-threading has seen. The error message is an invalid operation exception. It says the calling thread cannot access this object because another thread owns it. And what this means is I'm trying to access a UI element from not the UI thread. And it gets very upset at me about that. Okay, so I think I remember how to fix this, right? We have to marshal the call back to the UI thread and do a dispatcher.invoke and all of this other stuff. I remember doing manual threading. It was a lot of fun, wasn't it? Yeah, I don't have time for any of that. Instead, what I'm going to do is I'm going to use a different overload on this continuewith method. And I'm feeling like number 8 is the one that I want. So number 8, in addition to taking the action as a parameter, has another parameter, which is a task scheduler. The task scheduler is responsible for figuring out when tasks are supposed to run. Some of them have some preconditions. It can't run until some condition is met. The task scheduler tries to figure out, okay, what thread do I want to run this on? Do I need a separate thread? How are things going? So that's what the task scheduler's responsibility is for. Now, there is a static member on the task scheduler that we can use, which is from current synchronization context. It's a method. So hopefully you can tell exactly what from current synchronization context means by the name. Right? Yes. Thank you, Microsoft. Brilliant at naming things. Oh, wait, we're on the Visual Studio Twitch channel. So I think we all admit that Microsoft sometimes has trouble naming things. So what from current synchronization context means is, you know what? When you run this continuation, I'd like you to go back to the same place you were when we did assignment continuation. So right now, since I'm inside a button click event handler on the UI thread, I'm basically saying, you know what? When you run the continuation, go back to the UI thread. So just with this one additional parameter, now when I run the application, we'll see that it actually works. Yay! Okay, that deserves thunderous applause. No? Okay, not quite thunderous, but I'll accept it. It's been a long week. Okay, so this is what we have. And the thing is, this code is perfectly valid and it works just fine, but you will never, ever, ever see this in sample code that you look up online. Why? Because it's way too readable. Instead, we prefer to use Lambda expressions, right? Anyone at my Lambdas talk yesterday? Yeah, okay, you'll see the value here. So I'm going to walk through the steps of taking this and turning it into a Lambda expression. First, I'm going to inline the code by creating an anonymous delegate. So I'm going to delete this populate list box, type the delegate keyword, and then paste. And what I've just done is inline that method. So this will work exactly the same. I won't rerun it at this point, and I can remove this separate named delegate that we have below. Now, we can use Lambda expressions as anonymous delegates. Right here we have an anonymous delegate, so we can turn this into a Lambda expression. Let's go ahead and do that. This is magical. You just delete the delegate keyword and add the cool equals greater than sign between the parameters and the method body. Now we have a Lambda expression. Now it's not a normal Lambda expression because, again, it's way too readable. Lambda expressions have something known as parameter type inference. And what that means is if the compiler can figure out the parameter type, I don't have to type it in. So I can just say task here. Now this is still strongly typed. It is a task of list of person if we hover over it. And the compiler knows this because it already told us right here when we looked at the parameters, well, you need an action of task of list of person. So it has to be a task of list of person as a parameter. That's the only thing you're allowed to put in here. Now another thing with Lambda expressions is if we only have one parameter, we don't have to have parentheses around it. And so this will look more similar to what you will see online when you look at samples for using task. Again, the separate named delegate, i.e. method, works just fine, but this is what you see. So I do highly recommend getting used to the syntax, if nothing else. So, and I'll just run this because I know we've known each other for almost 25 minutes, but I see there's not a lot of trust going on. Okay, now I've just been like putting stuff up in my UI. Can I prove this is happening asynchronously? Absolutely. Anyone who's done desktop to development in the room? Okay. Everybody else, watch the expression on these persons' faces. Okay, you ready? Because I'm going to, oh, I have a clear, right? Yeah, clear. Watch this. Yeah. Watch this. That's amazing. I didn't block the UI thread. I didn't block the UI thread. Now, if you've done enough desktop development, then you will know all about the not responding thing. And if you just use desktop applications, you get not responding up in the title bar there. the worst thing you have to teach your users how to use Task Manager to kill an application, right? And whenever an application goes into a not responding state, our users have to say, do I need to wait or do I need to kill it? That's a terrible decision. So let's just take that off the table and not block our UI thread. So that's why I'm using a desktop application, because it's really easy to show that that task is happening somewhere else, not on the UI thread. Are you impressed yet? Okay. So here's the thing about task when we look at this. So it's not too much code that we need in order to do this, but we kind of have to know a lot of what I would call like intermediate level C# topics, right? Generics, nested generics, delegates, Lambda expressions, and don't get me started with this task scheduler.from current synchronization context thing. I won't tell you how long it took me to find that. Yeah, you guys can send me checks just for that little tip right there. So it's not exactly very approachable. And fortunately for us, the language designers are always thinking of how can we do things a little bit better. And that's when we got async and await. Now, when we talk about async and await, this is a syntactic wrapper around task. It still uses task underneath. It just hides a lot of the complexity. In addition to that, what's really nice about it is we can write our code the same way we always do. So it looks like synchronous code. It looks like code that would block a thread while it's waiting to do something before moving forward. So it's going to look like that, but it's going to behave completely differently. And that's what's really nice about it. Even though it looks like it would block, it doesn't. And when we talk about the async modifier, this is not like a magical thing that turns our methods asynchronous. What this is, it's a hint to the compiler. So basically, the problem is around the await word, because await was not a reserved word in C#. So there's a potential that people have used that as an identifier in their code somewhere along the way. So rather than saying we're going to potentially break people, the people designing this said, you know what, let's go ahead and create a scope. So if I mark a scope as async, then anywhere where I see this await word in here, I'm going to treat it like this special way. So that's really what the async is for. Generally, we see it at the method level. Very common to have it at the method level. Also, before a parameter with a Lambda expression or something like that. But it is a scope operation, so we can put it at different levels in it. So let's do this same operation that we just did, but we're going to use async await instead of task. And again, I have this cool method down here just waiting for us. Okay, Control KD to line things up. And since I'm a lazy developer, I'm going to let Visual Studio tell me how to program this. So I'm just going to say actually, I need a instance of my repository. Oh, wait, do I? Oh, actually, I don't. I have a new person repository at the top of my class, so I don't need to create that separate. So I can say repository.getAsync, and then just hover over this. The first thing I notice is the first word in this box, which says awaitable in parentheses. So it's telling me, you know what? You can use await with this. Okay, cool. How do I do that? Well, if I look down a little further, there's a usage section. And it says, okay, list a person X equals await get async. I can do that. That's pretty easy code. So again, I'm letting Visual Studio tell me all about this. So I can say list a person, I'm not going to say X, I'm going to say people, equals await repository.getAsync. Okay, now this isn't happy with me. And that's because even though I have await in there, I still need to mark my scope with the async modifier. Now, just a little warning, if you like the control dot help in Visual Studio, this will offer to add the async modifier for you, but it also wants to rename the method. It wants to say, okay, I want to tag async on the end of this because that's a best practice. I also want to make this return task instead of return void. Fortunately, I don't have time to talk about that. We don't actually want to do that on an event handler, which is where we are, because if we change the method signature, it's not going to work in the rest of our application. So I'm actually not going to use the little help thing, and I'm just going to type in the 5 async characters and the space myself. Okay, now what? Well, I have a list of person. Let's for each over it. A person listbox.items.add, just like that. Okay, this really doesn't feel like enough code, but let's try it anyway. Okay, so I click on the button, wait my 3 seconds. Okay, got data, it's working. Is this really asynchronous? That's really cool. I didn't have to do any of this from current synchronization context stuff. I just wrote code the way I normally write it. And it just runs from top to bottom with a little pause for 3 seconds in the middle just for fun. This is what's very valuable about await. And the primary reason this is in there is because, again, we've got 40 overloads on continue-with in task. It's very powerful. But using this structure covers about 95% of what most programmers need to do. So again, language designer said, hey, let's hit this 95% so they don't have to go through this. If someone needs more power, they can dig into task and handle it a little more. Now you might be wondering about that whole marshalling back to the UI thread thing that we don't have to do here. And that's because await defaults the other way. So it's assuming, which is a pretty good assumption, that if I'm in a method that I probably want to stay in the same context for the entire method, right? So it actually defaults to keeping the current synchronization context. Now just, if you've ever heard, like there's a best practice, like whenever you use await, you should say .ConfigureWaitFalse. You ever heard that? ConfigureWaitFalse, what does that do? Well, in our case, it breaks our application. Because what ConfigureWaitFalse does is it says, you know what? I don't care what thread you use when you're done with this. And so we end up with the same error message we saw earlier. The calling thread cannot access this because another thread owns it. So half of my method is running on one thread, the other half is running on another one. Now, we're usually told that we should use ConfigureWaitFalse when we're doing library code. And that's because if we're building a library, we generally don't care about the current thread. It's up to the person calling our asynchronous library to decide if they care about getting back to where they need to be. So in this case, I'm a UI developer, and I care about getting back to the UI thread. If I'm a web developer, I might say, well, you know what? I care about getting back to the thread I was on because that's where I've got my security credential. That's where I have something that's stashed in the session, right? So we do want to get back there in web applications a lot of times as well. But generally, if we're building a library, we don't care. But and the reason you'd want to add ConfigureWaitFalse is because there is a little bit of performance that you get from that. Because now the system doesn't have to grab the current context and then when it's done, get back to that context. So you're saving that overhead. The task scheduler underneath is saying, okay, I'm just going to use whatever thread is handy and just let's keep going. So again, in our case, we don't want to use this, but that's what that is for. We're stop debugging here and put this back. Now we do have a little bit of a problem with our application right now from a UI perspective, and that's because I can click on this button multiple times. I can click on it 3 times, and I see I get 3 sets of data that comes back. And we have exactly the same problem with our fetch with task. So we can see that our data is coming back. And so, of course, the first thing you think is, okay, Jeremy, you're an idiot. You're not actually clearing the list box. But actually, I am. At the top of both of these methods, I'm clearing out the list box. What's happening is I'm saying clear, 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 and then 3 seconds later, we get data, data, data. That's why we're getting this behavior. Now, I've had long discussions of the proper place to put this clear list box. Right? It's like, well, you should put it after the async call, or after you or before you populate the list box, or this, or maybe in all 3 places. But we don't want to overcomplicate things because realistically, this async method is making a network call. And if we just care about 1 set of data coming back, I don't want to make 3 network calls for that, right? So I'm going to take the simple approach, which is I'm just going to disable the button. So I'll say fetch with await button dot is enabled equals false at the top, and down at the bottom set it to true. Solutions don't always have to be difficult. So we can see now the button's disabled. I can't click on it again until things come back. Okay, what if something goes wrong in that asynchronous process, or I get an exception somewhere between disabling the button and re-enabling the button? Well, the nice thing about await is we just code the way we're used to coding. So I can just put in a try finally block. So I can highlight this block of code. I'm a lazy developer, so I'm going to say Control-KS, which is the keyboard shortcut for surround with snippet, and type in try F, which is for a try finally block. When I hit enter, it takes the block of code I had highlighted, puts it in a try block, adds a finally block, puts my cursor in the finally block so I can start typing lazy developer for the win. Are there any lazy developers in the room? Okay, real lazy developers don't raise their hands. So a really good idea of who the real lazy developers are now. Okay, and so I can just move this up into the finally block. And so the magical thing about await is we just program the way we're used to programming. Okay, let's do the same thing with the task button. So we'll come up here, and at the top of this, we'll say fetch with task button is enabled equals false. Down here at the bottom, say true. We'll run our application, and we'll click on our button, and it's not disabled. How many did I get back? Ooh, a whole lot. Yeah, and that's because of the way that asynchronous programming works. Because this will basically run immediately, because we're going to disable the button, clear the list box, call the getAsync method, assign the continuation, and then just re-enable the button and then exit the method. So this is just running straight through. And then again, 3 seconds later, our data starts coming. So we actually want to put this re-enabling of the button inside of our continuation. Okay, so not until after we the list box are we going to re-enable the button. And so now if we see this, we'll see we get the disabled state that I'm hoping for. Our data comes back and it re-enables. So now that we've looked at kind of how do I fetch data asynchronously and get something back, figure out how to get it into my UI, let's think a little bit about exception handling. What happens if there's an exception that's thrown in this asynchronous method? Well, in this case, since I jumped to the completed code, I've already got an exception prepared that's commented out. I will uncomment it right now. So this is now going to throw a not implemented exception on this asynchronous process. It's going to still wait the 3 seconds, and then it's going to throw the exception. So let's go ahead and save this and just see what our code does right now. And I'm going to start with the task button. So I'm going to click on the task button, and what we'll find is it stops on the result property. So the interesting thing about multi-threaded programming is that exceptions will stay on their own thread unless you go looking for them. So if I were to say, you know what, I don't think I'm going to this result property here, so let's say I comment out this code, for example. I can run this, we'll wait our 3 seconds, the task will run, the exception will get thrown, but it's going to stay on its own thread because I haven't gone and looked for it, so our button re-enables. But by trying to access the result property, I've just said, you know what, I care about this task, give me the result. Now when a task gets an exception, it goes into what's known as the faulted state. And in a faulted task, result is invalid. So if I try to access result, it's going to show me the exceptions that I get. Okay, the unfortunate thing is when it shows me, one of the unfortunate things, when it shows me the exception that it gets, I would hope that I would get that not implemented exception. But actually what I'm getting, I'll read it to you instead of trying to zoom my screen, which would kind of be a disaster at this point, is I get an aggregate exception. And the message is very helpful. It says 1 or more errors occurred. You might say, okay, what is this aggregate exception? Well, we'll come back to this in a bit. First, let's see if we can figure out how to take care of not dealing with this. Well, task has some properties on it, which are the is properties. There's an is canceled, is completed, and is faulted. And we can actually use these to decide what path our code's going to take. So I can set up a if statement to say, well, if the task is faulted, then I'll go ahead and do a messagebox.show, and we'll show the exception. So we'll say error, then task has an exception property on it, and I can just look at the message of that and pass it through. And then I could put an else here and follow my happy path, but instead of doing that, I'm thinking about, okay, well, I want to deal with cancellation as well, so I'll just add a little canceled block to say deal with cancellation. And then I'll say if task.is completed, okay, and then our enabling the button is back outside of all of this. Okay, so this code looks pretty reasonable, so let's go ahead and run it, see what we get. So we click the button, we wait our 3 seconds, we get a pop-up that says error, 1 or more errors occurred, and then when I say okay, why am I in this block of code? Well, this really bothers me because is completed does not mean what you think it means. If you actually go and look at the documentation, is completed means no longer running. It does not mean completed successfully. The actual documentation says is completed will be true when a task is in one of 3 final states: faulted, canceled, or ran to completion. When I see these 3 is properties together, I'm expecting that they're mutually exclusive. So this really bothers me. Fortunately, there's another thing that we can use, which is the status property, task.status. And this is an enum, so everything is mutually exclusive. So I can say if task status dot, and we can see here we have canceled, created, faulted, ran to completion, which actually does mean completed successfully, and then some others that have to deal with, am I in a waiting state, am I currently running, etc. So if I do that, now what we'll find is that my code will behave as I expect. So I click the button, wait my 3 seconds, get my pop-up, I clear that, my button re-enables. Okay, so I'm hitting the right paths here. So how do I get to the real exception? Well, it turns out that this exception that comes back from task is an aggregate exception. And this is because task is very powerful. I talked about a task that could fire off 5 child tasks. And let's say we have those 5 child tasks running. 3 of them complete successfully, 2 of them throw exceptions. Which exception should I give you? The one that happens first? First is a very dangerous concept when we're talking about concurrent operations. Because first on my machine might be different than first on your machine. First on my machine might be different depending on what else is running at the time. So instead, what we get is an aggregate exception, which is a tree structure. So it returns all of the exceptions to us. Now you might say, okay, well, I get that aggregate exception. I just look at the inner exceptions collection just like any other exception, and I can look at that. Well, those inner exceptions are also aggregate exceptions, and it's basically aggregate exceptions down. Now, before you go out and start building a tree parser to get to the real exceptions, let me show you a magical method, and I won't tell you how long it took me to find this, because aggregate exception has this magical method called flatten. And what that will do is it will take that tree structure and go and make a single level of exceptions that I can iterate through. Now I'm going to do something that I will say, never, ever, ever do this to your users. This is strictly to demonstrate what is possible, but I'm going to for each over this. For each exception in our flattened exceptions, and then we will show those exception messages to the user. And I do not ever, ever, ever show a raw exception message to my user. This is strictly something that I can show you that this works. You can get to the real exceptions. They have the full stack trace. So if you want to iterate through them and send them to your logger, do that. And then you can figure out what caused them, hopefully put in some exception handling so that you can deal with it at a better place in your code. So now what we'll see is the pop-up actually gives us the message, and it actually says get async method is not implemented. So now I know that I'm looking at the actual not implemented exception that my particular task is throwing. Okay, that was a lot of effort. Okay, how do we deal with exceptions in async? Okay, well, first let's run it and let's just see what the behavior is right now. Okay, so I click the button, I wait the 3 seconds, I actually do stop, and it stops on the getAsync method call, which is where I would expect it to, for example, if this was a synchronous operation. Even better, the message that I get is the not implemented exception. It says getAsync method is not implemented. So await actually unwinds that aggregate exception. Instead of giving us that, it's like, okay, here's the exception that you really want. Okay, so here's a question. How do I deal with this exception in this block of code? Are there any ideas? Catch block, yes, I'm already in a try block. All I have to do is add a catch block. So I'm going to just kind of do a global catch right now, and we'll see why in just a bit. I'm going to catch exception. And then I'll do the same thing that we did above with the message. And now we can run this and see how this behaves. Okay, so we run, we hit our catch block, we get our pop-up that says getAsync not implemented. Await is pretty awesome, isn't it? Makes things really easy. Okay, so now we've seen, how do we get something from an asynchronous method? How do we kick off that method, do something after it's done? We've also seen how do we handle an exception. The next thing I want to look at is what do we do about cancellation? And this is another thing that I had some hurdles with, right? So, we've seen some of my hurdles already, like the from current synchronization context. We've seen the aggregate exception, and I won't show you the tree parsing thing that I built to try to unwind that. I actually ran into some issues with cancellation as well. Now, since this code has already been completed, it looks a little bit different than the code we saw earlier. Go ahead and comment out that exception. Because I added a parameter to this getAsync method. So this getAsync method has a cancellation token as a parameter. Now, I didn't want to break any of my existing callers or any callers that didn't care about cancellation, so I added a default value for that. So we can see that parameter says cancel token equals new cancellation token. What that will do is if I don't supply a value, it will give me a cancellation token that's in the not cancellation requested state. I love talking about cancellation. The terminology is great. Because cancellation in this world, it's not a halt, it's not an abort, it's not a kill. What it is, it's a flag that says, if you care, somebody would like to cancel this. If we never go check that cancellation token, nothing's going to happen. So it's really tempting to say, okay, well, let me check a status on the token. If the token is in a canceled state, then I'll do all this other stuff. But we've kind of seen already what needs to be done. Well, that is canceled property is going to have to be set to true. The task status is going to have to be in the canceled status. Result is going to be invalid and some other things. I don't know how to do any of that. So instead of trying to do that manually, I'm going to tell you to call a method that a lot of people push back at. And this method is already in here. It's this line of code right here, right above this exception. And this is a method on the cancel token, and it's throw if cancellation requested. People push back against this because it has the word throw in it. And throw implies that there's an exception happening in here. And we're told as young developers, don't use exceptions for flow control, right? Don't use exceptions for flow control. Don't use exceptions for flow control. And that's actually very good advice because exceptions are expensive from a computational standpoint. Whenever an exception gets thrown, has to unwind the call stack and package everything up and figure out where we're in and breaking and what do we do, and then give all that information back to us. So we're told don't use exceptions for flow control. This is one place where I'll say, let that go. An exception to the rule. The people who built this knew what they were doing. And we'll kind of see the importance of this. So we'll do this throw of cancellation requested, and then the infrastructure will take care of making sure the status is correct, the is canceled is true, the is completed is true, et cetera, et cetera, et cetera. So we'll do this. And what I'll do to test this out, actually before I do anything, let's just run and make sure my happy path still works for both of my buttons. Okay, so there's my 3 seconds and data, and there's my 3 seconds data. Yes, that makes me. But I have this cancel button, which I need to play. It's already got code in there. Rid of that code for them. So I'm going to start with the task. And what I'm going to do is, rather than hooking up the button to start with, I'm just going to give it a hard-coded cancellation token that is in the cancellation requested state. And I can do that with just the constructor. So I can say new cancellation token, pass in true as the parameter. So when I create a new cancellation token with the parameter of true, it will create a token that's in the cancellation requested state. And so now let's run this and see how this behaves. So I click on my button, I wait. All right, there's another piece of code in here that I need to remove. That's actually a cool thing that we'll want to do later. That's what happens when I skip ahead. Okay, so we'll click on the button, it's disabled, we'll wait our 3 seconds, and then after 3 seconds, we'll see the button re-enables, nothing else happens. That's actually exactly what I expect right now, because I have an if block in my continuation, wrong file, that just has a comment in it that says to deal with cancellation. So I can come in here and do a message box.show and just say canceled, like that, so that I have some clue to the user that this process has actually been. So now when we run, when we click our button, we wait our 3 seconds, we'll get our pop-up that says canceled, and then when I say OK, it will re-enable the button. Now, one thing that I don't like here, but unfortunately I don't have time to fix it today, you can go online and look at the sample code to see where I end up. I don't like these ifs. I don't like that I'm seeing the is faulted, is canceled with the task.status. So I'd actually want to make all those the same and maybe even use a switch block. So you can go online and see that completed code to clean it up a bit. So we've seen how we can handle this just from a kind of mechanical standpoint. Let's do the same thing for await. So I'll come in here, and in my getAsync method, I'll just hard code a cancellation token that's set to true. And let's see how our application behaves. So I click the button, I wait the 3 seconds, and I get my pop-up message. It says error. This is my exception handler. And it says the operation was canceled. Why is it doing that? Well, let's look at this code and think about it a little bit. So in the code that I have here, I don't have a task. The task is hidden from me. So I don't have a property I can check. I can't check the is canceled property. So how else would I know that this asynchronous method has been canceled? And again, the language designer said, you know what, let's throw an exception. It will be an operation canceled exception, so we can catch it and handle it separately if we need to. But that way our code can work kind of just like our normal synchronous code. And that's what makes it so great. So I can come in here and let's just catch operation canceled exception. Canceled. Actually, send in ex.message. Did I do that wrong? My $ is not there. That's why the telesense. That's not a $. Oh boy, it's a good thing I'm almost done. I can't type anymore. Okay, so let's try that again. Okay, so there we have our canceled box comes up, and it actually gives us the message of the exception. The operation was. But I do want to hook it up to this button. So here's what I'm thinking. Okay, don't look at this. And that didn't exist. I'm thinking I need a cancellation token that I'm going to pass to my methods, right? And doing this hard-coded token thing isn't going to work for me. So what I'm going to do is I'm going to create a class-level token. So we'll say cancellation token, cancel token, and let's new it up. Token. And I'm just going to leave it in the default state, which is cancellation, not cancellation requested. And then down here in my cancel button underscore click event handler, I can say cancel token dot cancel dot stop dot halt dot stop. So it turns out that if you create a cancellation token yourself using the constructor, you can't change it later. So I can create it with a true or false as a parameter, but I can't change it later. That's not very useful to me. And you might say, well, wait, Jeremy, there's this property, is cancellation requested? That's a read-only property. Can't set it. I won't tell you how long it took me to figure out how you're supposed to do this. My biggest recommendation is read the documentation. Okay? Read the documentation. Because we're actually not supposed to use a cancellation token directly. Instead, we're supposed to use something that's known as a cancellation token source. So a cancellation token source is an object that's responsible for managing a cancellation token. So this does have, let's go back down to our cancel button. So I can say token source dot cancel. Hey, it has a cancel method. I like that. It also has a dot token property. So that's a cancellation token that I can pass to my method. Awesome. I'm going to say dot cancel here. There is also a cancel after method, which I think is kind of interesting because it allows you to put a time span or number of milliseconds in. I like to just put a random time span in there just to mess with my user sometimes, but not exactly recommended. Okay, let's start with the fetch with await button. And instead of using this hard-coded cancellation token as a parameter to my async method, I'm going to pass in the token source's token property. Okay, so that'll take care of that. Now I have to do one other thing, and that's at the top of this method. I'm going to create a new instance of a cancellation token source. The reason I'm doing that is that there's no way to uncancel a token. So at the beginning of each of these processes, I want to start out with a fresh cancellation token that's in the not canceled state. Now the thing is, if you think about, well, why can't we put it back? You can use the same token and pass it through an entire chain of processes to a whole bunch of objects. What if you set it to cancel and these things start canceling and you wait, oh wait, no, stop canceling, and these other ones keep running? It would kind of be chaos. So cancellation token is a one-way operation. You can say, yes, please cancel, put it in a cancellation requested state, but there's no way to go back. So if I want a fresh token, I need a new fresh token source. And with this code, I should have a working cancellation. Let me go ahead and just click it and let it run through its normal process. Awesome. Now let's do that. I'm going to click the cancel button. I still have to wait the 3 seconds because we're not checking until after that, and I get my pop-up that says cancel. I can do exactly the same thing with the task button. So we'll change our new cancellation token to the token source's token property. Will be a new. And now we'll see that our task button works as well. So we click on that, wait our 3 seconds, we get data. Click on it, hit cancel, and then we'll see we get our cancellation pop-up. Now usually people say, do we have to wait those 3 seconds? The answer is absolutely not, as we saw earlier, completely by accident. And that's because most asynchronous methods have an optional cancellation token parameter, including task.delay. So task.delay does have an optional cancellation token. So I can pass that in. And then down here, I have some other async methods. I get async on HTTP client also has a cancellation. So I can use the same token for all of these. And when I do that, then what I'll see is I don't have to wait the 3 seconds. I get immediate cancellation. Immediate cancellation. So that's really cool. Wow, I actually made it through everything, which I'm very surprised. Let's just wrap up some of the things that really, really kind of got me when I was going through this process to start with. Again, these properties on task, is canceled, is completed, is faulted, very compelling. Is completed does not mean what you think it means. It means no longer running. It does not mean running completed successfully. But there's a task status. And that is an enum that has a ran to completion on it. Enums are mutually exclusive, so that's a single state it's going to be in at a time. When we're talking about exception handling, again, aggregate exception that comes back from task is a tree structure. There's the magical flatten method on that, which will turn it into a single level that you can send to your logging system. Again, please do not iterate through them and show them to your users, but it is available to you. And then when we're talking about cancellation, if we were to create a cancellation token ourselves, it's read-only. We can create a true or false, but we can't change it later. What we actually want is a cancellation token source. It has both the token property we can pass along, as well as the cancel method. So that's a whirlwind tour of task and await. I hope it was useful to you. I thank you very much for hanging out to the very tail end of the conference with me. If you have any questions, I'll be hanging around afterwards, or you can shoot me an email a bit later on if you come up with something later. Thank you very, very much for coming.
Hey, everybody. Thank you, Jeremy.